grade 10s, and welcome to today's session of Learn Extra. My name is Hayley and I'm going to be taking you through the session. Today we're going to be dealing with measurement. So let's take a look at what kind of measurements we're going to be dealing with. So our key focus for today is basically our everyday measurements. They're the measurements that we use on a daily basis, and we really don't even realize that we're using the maths every day. So those include mass, temperature, length, move down a little bit, distance, we've got time and speed. Those are the few measurements that we're going to be dealing with today, and honestly we're just going to take it step by step, slowly, and just discuss the measurements that we see every single day. So, starting off with mass. Well, in actual fact, in everyday language we don't talk about mass. We talk about weight. Now, I know the science teachers and the scientists around there are going to say, oh, there's a difference between the two. But in Maths Lit, we really don't worry about the difference. We talk about how much does something weigh. We don't say what is the mass of something. But the reality is that they are different, and we should be talking about mass, but we're going with everyday stuff. So we're talking about weight. Now, how do we measure this mass? Okay, we can use a scale. So, if you're worried about your weight and you want to lose weight or you want to gain weight, what do? You would get onto a scale, maybe a bathroom scale, and it will tell you how many kilograms you are. If you were cooking, you would use a scale in a different way. Okay, you don't want to necessarily know kilograms, maybe you're going to go down to the grams. We'll discuss the units again in a second. So we can use a scale. So we've basically got different types of scales. We've got kind of larger scales. There's a wonderful example of a scale. If you're driving along the roads, on the highways, every now and again you see what they call a weigh bridge. Okay, so I'm going to actually write that down. We've got a weigh bridge. And what are those weigh bridges? Those are for those huge big trucks that we see on our highways and on the roads. They need to go over this huge scale to actually weigh how big and how heavy the truck is, so that they know whether they can continue along the road. And the reason they do this, guys, is because the heavier the truck is, the more damage they're doing to the road. So they need to know, and there's maximums weight that can carry on that road. Right, what else have we got? We could use a balance scale. That's one of those scales where, you know, you've got two dishes and you need to try and balance them, or they move up and down, so that kind of scale. And there's another one where we've got a spring scale. And that's a balance which is adjusted to a spring. I don't have one to show you, unfortunately, but adjusted to a spring, you put your weight at the bottom and it tells you how heavy the mass of the object. But speaking about objects, let's look at my two objects here. I've got two tins, and they look exactly the same. So what I want to tell you about this mass is that it can be deceiving, because what looks exactly the same, these two tins, in actual fact is different. So let me put one down. Right, this is empty. So if I had to put this onto the scale, it will weigh fairly little, so it's empty. Whereas my other tin, if you open that up, you'll see that it's got a huge rock inside. I hope you can actually see this clearly, and it's quite a lot heavier. Now, if I had to put these onto a balance scale, what's going to happen? My heavier one is going to go down, so my lighter one is going to go up. And if I had to put it onto a scale to measure the grams, well, I'm expecting the one with the rock in to be more. Right, let's carry on with the units. So what have we got? Units. I think I've mentioned a lot of the units. We can deal with grams. An example of that would be in cooking. We would talk about kilograms. And then the kilograms, or an example of that would be, say, a person. Okay? Or furniture, maybe. And then we can deal in tons. And that would be my truck. Whoops, can't spell today. That would be my truck. And there's another one that we use, and it doesn't happen very often, but you will see it in the questions that are asked. And I should have actually put it on before grams, because I'm going a little bit bigger, and that's milligrams. And milligrams are really, really small. So where do we use milligrams? Usually in medicine. Just to quickly remind you of the conversions, we have 1,000 milligrams in 1 gram. We've got 1,000, can't see that one, 1,000 grams in 1 kilogram. And we've got 1,000 kilograms in 1 ton. So mass is actually fairly easy because you just have to remember the one number, it's 1,000. Hey, let's move on and try answer some questions. Our first question is, the mass of a 5-cent coin is 7,250 milligrams. Well, there's another example of where milligrams come up in everyday life. We measure 5-cent coins in milligrams. Okay, we would need a scale that measures milligrams. So 7,250 milligrams. Find the mass of 10 rands worth of 5-cent coins and give your answer in kilograms. Now this is an important fact. I always want you to read the question carefully and check what do they want the answer in, because you need to keep that in the back of your mind that the question wants a specific answer, and in this case it was kilograms. So if possible, we're going to convert to kilograms as soon as possible because it'll just make it easier for us. In this case, it's going to be a little bit hard for me to convert to kilograms because I've got 7,250 milligrams and I'm going to have to divide it by 1,000 to get grams and another 1,000 to get kilograms. So it's going to end up with this very, very small number. So rather than converting now, I'm going to convert at a later stage. So what's the first part of the question? We want to know 10 rands worth of 5-cent pieces. So I need to know how many 5-cent pieces. I want to know how many is 10 rands worth. So what I'm going to do is I'm going to take my 10 rand and I'm going to divide it by my 5 cents. And I'm going to see, well, how many actually go into the 10 rand? But there's a problem with this question. What's the problem? I cannot convert rands by cents. So what am I going to do? I'm going to have to convert one to the other. So let's convert our 10 rand into cents. So we've got 10 rand and we times by 100. Why? There are 100 cents in a rand. So we times that by 100 and then we're going to divide, and we no longer have rands, sorry. That is now 1,000 cents, and we're going to divide it by 5 cents. Oh, now let's use our calculator. I like using the calculator. Guys, you've got the calculator. Don't think, well, I actually know how to do this calculation and it's very simple. Check it on your calculator, because sometimes what happens, you get into like a little bit of a panic. You think you know what the maths is and it seems simple, and then you do a silly calculation error, leave off a 0 or something silly. So you've got the calculator, use it. So we're going to say we had 1,000 and divide it by 5, and we get an answer of 200 coins. So let's go back there and write in our answer. We had 200 coins, 5-cent pieces. Now we want to know how much they weigh. So I know, and this is a little bit of a ratio, I know that 1 coin weighs 7, that's not a 7, 7,250 milligrams. I want to know what 200 coins weighs. And can you see the way I've written it? It actually looks like a ratio. So what I'm looking at, what did I do from 1 to get to 200? I times by 200. So I'm going to do the same thing here. I'm going to times by 200. So let's find a little bit more space. So I'm taking my 7,250 milligrams and I'm going to times it by 200. And let's see what answer we get for that. So 7,250 and we're going to times by 200. And I get 1,450,000. So let's write that in. 1,450,000. Always double check how many zeros you have. when we have this huge big calculation. These are milligrams. What did my question say? I needed it in kilograms. So I'm going to convert. So what I do first, I'm going to take it in 2 steps. And I always find it easier to do 2 steps. Rather than going from milligrams to kilograms straight away, let's go to that one in between. So we had milligrams, we had grams, and then we had kilograms. So let's take one step and then the second step. So first step will be dividing by 1,000. Now, if you'd like to use your calculator here, you can, but this one I think you should be able to do without the calculator. So what do we do when we divide? We can cancel our zeros. So let's get a different color and show you that I can just cancel 3 zeros. So what am I left with? 1450, and that's grams. Now I'm going to take the second step and divide by 1,000. And this one I'm going to use my calculator because I don't have that many zeros anymore. So let's use the calculator, 1450, and divide by 1,000. And check that you've entered the correct number on the calculator, and I get 1,45. So go back to my question. So we end up with 1,45 kilograms. Now that's quite an interesting actual calculation for me. That 10 rand worth of 5-cent pieces weighs nearly 1.5 kilograms. Now imagine taking that 10 rand to the shops to go buy your bread or whatever it is. But 5-cent pieces are so easy to collect because we kind of don't tend to spend them, but we need to be able to kind of lug this weight around, this very heavy. All right, let's move on to the next part of the question. All right, and here's a picture of a balance scale. So a simple balance was the first way people used to compare masses. Right, so what we have with a balance is we have 2 trays, and we're literally balancing one up against the other, and the heavier one, like I said earlier, will be lower than the lighter one. When the pans are level, the masses in the 2 pans are equal. So when they're level, the masses are equal. A trader finds that 3 bags of rice have the same mass as 2 bags of flour. So what did this trader found? He found that they were balanced, they were equal. So 3 bags of rice and 2 bags of flour. Which will have more mass, 4 bags of rice or 4 bags of flour? So let's go back to the question. We had 3 bags of rice is equal to 2 bags of flour. That's what he's discovered. Now we want to know if we've got 4 bags of rice and 4 bags of flour, which is going to be heavier. So my question to you is, what have I done here? The flour, you can see I've doubled. From 3 to 4 bags, I've only added 1 more bag. It's less than double. So which is going to be heavier? Well, clearly, my flour is going to be heavier. So let's say my flour is going to be heavier. So what will happen? My flour will actually be lower down. Right. If I put 5 bags of rice on one pan and 3 bags of flour on the other, which pan will be lower? So now we have, okay, let's go back to our original question. We had 3 rice is equal to 2 flour. Now I want to know if I put 3 bags of flour, 5 bags of rice, and 3 bags of flour, which will be heavier. Now in this case, I'm going to actually have to look at the ratios. Here it was quite easy. I could see I was doubling here and not doubling there, but I'm not doubling in either place. So I'm going to have to look at which ratio is bigger. So if I look at 3 over 2, is that bigger than 5 over 3? So we're going to compare 3 over 2 to 5 over 3. That's what we're going to do. So I'm going to use my calculator and say, well, okay, if I say 3 divided by 2, what do I get? I get 1.5. So what I'm telling you is, this is, this is 1.5. Get a pen, let's get a different color. That's 1.5. And the 5 over 3, let's do that one. 5 divided by 3, and I get 1.67. We're going to round off to 2 decimal places. So 1.67. What I'm telling you is that I've increased the flour by 1.5. I've increased the rice by 1,67. So this is a 1.5 increase, and this is a 1,67 increase. So which one do you think will be heavier? Well, clearly the one with the bigger increase. So I'm going to go with, in this case, the rice is bigger. The rice is bigger. Not bigger, let's go heavier. Can't spell today. Right, the rice is heavier, and that pan will be lower. So that was the question, which pan will be lower? Right. I want you to get into the habit of rereading your question, and I think I've said this before. If you've been watching me on the show, you've heard me say it a few times, and I'm going to keep saying it because I think it is so important. Reread the question and double check that you've actually answered the question correctly. So we have answered the question because we rechecked. We needed to say which pan was lower. Right. What must I do to get the pans to balance? Well, we started off with a balance of 3 rice to 2 flour. So that was our balance. But now what must I do to get them to balance when I've got more bags of rice and more bags of flour? What I have to do is I have to increase it in the same ratio. So we need to basically increase in the same ratio. What do I mean? If I increase that to 6, I've doubled it. Then I'll increase this to 4. I've doubled it. If I increase it by 3, okay, let's do one more. So if I increase this by 3 times and make that 9, I'm going to say, well, that's 3 times, and I'm going to make that 6. So I need to keep it in the same ratio, so that when I simplify the one to the other, I still get back to my 3 to 2. Let's move on to the next part of our lesson. So now we are going on to temperature. How to measure temperature? Well, first way to measure temperature, and I hope that you can see this clearly, is with a thermometer. So this is a thermometer, and I know on camera it's not going to come out very clearly with what the numbers are. So I'm going to tell you that I'm reading this off, and it tells me that it's 27 degrees Celsius. So we're using the thermometer, and we can read where the line of the mercury goes up to, and in this case, 27 degrees. I can also use a digital thermometer. Okay? So my digital thermometer gives me a temperature. Well, this one gives me a little bit more. It gives me a time, and it gives me a date, and I don't think it's correct at the moment. And at the bottom, you'll see that it gives me a temperature. And I'm not sure how clearly you can see this, but it says 21,4 degrees. So clearly my 2 thermometers are not the same, and I'm going to guess that this one might be a little bit out. So that's another way that we can read it. So we've got a thermometer. Our units that we use to measure temperature, we've got 2 different types of units. We in South Africa use degrees Celsius. We use the Celsius scale, and it makes so much sense to us because why does it make sense? We've got 0 degrees Celsius is the melting point of water, okay, and 100 degrees Celsius is the boiling point of water. It makes total sense. It's our metric system, goes from 0 to 100. We like those round, even numbers. On the other hand, in America, they use Fahrenheit scale. And this Fahrenheit scale is slightly different and has never really made any sense to me. The Americans seem to like it. 32 degrees Fahrenheit is the melting point of water. And why I say it doesn't really make sense to me is it seems such a random number, but it works. 212 degrees Fahrenheit is actually the boiling point of water. So basically what I'm telling you is that if I had to compare one to the other, where I had 0 degrees Celsius here, I would have 32 degrees Fahrenheit. And where I had 100 degrees Celsius here, I would have 212 degrees Fahrenheit. We do have a system to convert one to the other. It's quite an easy, well, a little bit more complicated mathematical formula. Let's see if I've got the formula somewhere. Or maybe I don't. But at any rate, you will get the formula at some stage where you might have to convert one to the other. And we just deal with like a formula, not a problem. Right, let's go through to question 3. There are 3 thermometers below and they indicate different temperatures. So whenever I get a picture, what I like to do is analyze the picture, analyze the table, analyze everything before we carry on with the questions. So I've got 3 thermometers, A, B, and C. Right, so A, on this thermometer, firstly, what I can see is, and I wonder if this will come out, I've got Celsius and Fahrenheit. So it's a great way to convert one to the other. So I've got, and my temperature, you can see, is at that point there. Then I've got B, which is again the same type of thermometer, and I've got a lower temperature, and C with a very low temperature. Can you see our numbers are really going from -10 to 110 degrees Celsius and from 20 to 220 degrees Fahrenheit? Let's read the question. Where do you think each of the thermometers are? Well, that's a really nice question. So let's look at our temperatures and decide where we think they are. The first thermometer, the temperature is 100 and just over 110 degrees Celsius. Where would we think to find that? Well, I would find that thermometer maybe in an oven, because I can put my oven on to a fairly high temperature. Or maybe the thermometer, if you check your meat, you check with a meat thermometer, you check to see how hot the meat is in the center, that would be maybe 110 degrees. The second one is just over 20 degrees. And where would we find that? Well, I think that that would be room temperature. You know, the thermometer that I showed you earlier was about 20, just over 20. And finally, at -10 degrees. Now, this is really nice, at -10. Remember when we did numbers a couple of weeks ago, we were discussing whether we had positive or negative numbers and where we see negative numbers, and this was one of the examples. So I'm glad it came up today. We have a -10 degrees Celsius, a -10 degrees Celsius, and I think that that would probably be in my freezer. My freezer's thermometer would be below freezing point. Let's estimate the reading on thermometer A in degrees Celsius. Okay, it's above 110. It doesn't give us any more numbers, but we can look at the distance between 110 and 105. It's about the same, so I'm going to go with that is 105 degrees. 100, sorry, not 110, 115. 115 degrees Celsius. And finally, what is the reading in thermometer B in degrees Fahrenheit? So B in Fahrenheit will be between 60 and 70, and it's going up 65, then there's another point, so we've got 4 lines in between, so it's going to be in between, so we're going to say, well, it is 75, let me find my space here, 75 degrees Fahrenheit. And I've got the formula now, but I think it might be a good idea for us to take a little bit of a break and come back and we'll tackle the formula after your break. So go get something to eat quickly, have a drink, and hurry back because this formula is really important. I'll see you in a few moments. Welcome back, guys. I hope that you got something to drink and that you're all ready to go for our next session. So let's carry on going through the temperature and see what our formula says. So our formula says, use the following formula to convert temperatures. So I want to read the formula first and understand it. What my formula basically says is that I have degrees Fahrenheit, and if I want to convert to degrees Fahrenheit, I use this particular formula, and I take my degrees Celsius, I multiply by this fraction, 9/5, and then I add 32. Now remember, 32 was that melting point, melting point of water. So, no, sorry, the freezing point of water. What is the temperature in degrees Fahrenheit? In today's temperature is 24 degrees Celsius. So what I'm going to do, whenever I get a formula, the first thing I do is always write out the formula. Because I find if I write out the formula, then I don't have a problem substituting in the values. So take those extra few moments to just write out the formula, and then you've got it there. So, and we will always be given the formula. So my Fahrenheit is now 9/5 times my degrees Celsius plus 32. And now I'm going to take a different color and I'm going to substitute in So now I've got my F is actually 9 over 5 times how many degrees? Well, it was 24 degrees plus 32. And this is really important when you guys are doing calculations like this and converting, if you're only using the 4-function calculator. I've got a scientific calculator, so that will work with BODMAS. But remember, if you don't, do steps. So let's pretend it's not a scientific calculator, and let's try this on its own. We're going to say 9 times by 24. That's my top. And I'm going to equal that and divide it by 5. Press equals, and then I'm going to add the 32. So did you see the steps that I took? I pressed equals in between so that I don't have to worry about what BODMAS is doing. So I don't want to add before I multiply. And my answer is 75.2, and let's write that in. So that's equal to 75.2, and don't forget your units. So what are we dealing with? We want our answer in degrees Fahrenheit. So always remember you need a unit. Next part of the question says, the weather report gives the temperature in New York as 52 degrees Fahrenheit. What is this in degrees Celsius? And now let's do that calculation. So again, we've got the formula. So let's write out our formula. So we've got that F is equal to 9 over 5 times C plus 32. And in this case, we're going to have to manipulate the formula. Now, I have a feeling that they might give you the formula in the other way, with degrees Celsius is equal to. So, but let's work through the formula anyway. So, we know that 52 degrees is equal to my 9 over 5 times C plus 32. And what I need to do here is I need to get C on its own. So I'm going to do the reverse of what happens. I'm basically going to get rid of my 32, so I'm going to minus it. And I'm going to do this in a few steps. So I'm going to say 52 minus 32 is equal to 9 over 5 times C. And then I can do that calculation already, so I know that that's 20 is equal to 9 over 5 times C. And now I need to get C on its own, so I'm going to do the reverse of what's here. So let's get another color, and I'm going to times this by 5, because then those cancel. And I'm going to divide by 9, because then those cancel, and I'm left with just C. But what I do to the one side, I need to do to the other. So I'm going to say 5 over 9. Let's get our calculator. So now we end up with C on its own. Can we see that we've got 5 over 9 times 20 is equal to C. Everything else disappeared. So let's do that calculation. I'm going to say 5 times 9. Again, I'm going to 5 times 20. Okay, and you need to check your calculator. 5 times 20 and divided by 9. And I get an answer of 11.11. So my answer is 11.11 degrees Celsius. Now, while I was doing this calculation, I was actually thinking to myself, am I expecting a bigger number or a smaller number? And if you noticed throughout this temperature calculations, our Fahrenheit was always higher than Celsius. So I knew that I needed a smaller number. When my calculator comes up with a smaller number, then I'm always happy with that, because now I think, oh, well, check that, tick, it's what I'm expecting. That's what I want you guys to do. Think about the question, think about the answer. Does it make sense? If I got an answer that was bigger, I would think to myself, bells are going off in my head. There's something wrong. Doesn't make sense. That's what I want you to do. Think, guys. Think about the answers. Right, let's move on. We're now going to be dealing with length and distance. So, first question I have is, how do we measure length? Well, you know what? Before we discuss how to measure length, let's look at some of my props that I have here. I have a tape measure, which basically we would use, this kind of tape measure we would use for sewing, like a sewing pattern. Or possibly, if I'm trying to lose weight, I would use this kind of measurement to measure the distance around my waist, okay? And then maybe I can measure it in a couple of weeks, and hopefully it's going down and not up. But if you want to gain weight, maybe this is one way you could do that. Okay, so we could use that. I've also got a measure that you would use if you were trying to measure how much your curtains, if you wanted to measure for curtains, you would use something that is stiffer, whereas this, if I had to try and measure in the house, is going to cause me a huge problem. And this kind of measurement would be much easier. So I could hook it onto the top of the curtain rail and measure down and read off the measurement. So what's important is that both of these have the ability to read, and we can read them in centimeters. I can also think of a couple of other ways that we can measure. So if I want to measure in kilometers, for example, my car measures kilometers. As I'm driving, it goes through, the odometer keeps ticking over how many kilometers I've driven. So there's lots of different ways that we can measure things. Right, so how do we measure? And we're dealing with length. You, in your pencil case, should have what, and I don't have one to show you, but I know you've got one in front of you, a ruler. That's one of my colleagues always says is our little cheat. We've got one of these rulers with us all the time in every exam, and that's for measurements. Right, so we've got measure of length, we've discussed how many. I don't think I need to write them down. Oh, go back to my units, right. So what would we measure length in? So I could measure length in centimeters. Everyday language, I would deal in centimeters. If I was going to measure my waist, I would talk about centimeters. And then I've got meters. We can measure then further in kilometers. There are measurements in between, but we don't really deal with them in everyday language. So we really only deal with centimeters, meters, kilometers, and possibly, again, I've left out the millimeters. So those are measurements that we use in everyday language. Remember, Maths Lit comes down to everyday stuff. Let's just quickly convert what, remind us of our measurements. Now, I know we've done this before, but I'm just going to do it quickly again. We've got 10 millimeters in 1 centimeter. We've got 100 centimeters in 1 meter. And finally, 1,000 meters is 1 kilometer. Can you see that these measurements are a whole lot harder, than the ones that we did with maths, where we were just dealing with 1,000. So now it's important to remember which one we're converting. And guys, you're going to practice these conversions. So whether you're going to be using King Henry or whether you're going to be using another system and just remembering these values, you will get into the habit of being able to convert from one to the other. Not complicated, just a little bit of practice needed. Right, let's go through to a question. So we have our question, and our tailor needs to be very good at measuring the length of fabric required to make suits and dresses. So imagine what happens if the tailor is not good at these measurements. Then you're really going to end up with clothes that don't fit. I'd hate to pay a tailor for something that doesn't fit me exactly the way I want. So he needs to be very good at this measurement. The use of patterns to make sure the articles they are sewing will fit a person has ordered it. Right, person who has ordered it. So they use a pattern. So this is an example of a pattern to make a pair of pants. So the pattern for trousers states that 2 meters of material that is 1.5 meters wide is needed. So for every pair of pants, he needs material that is 2 meters long and 1.5 meters wide. Now that's a really important when it comes to material. I'm just going to discuss it for a second. Material, you might fall in love with a piece of material, but it's not wide enough. They make material to certain widths. And in this case, the tailor needs material that is 1.5 meters wide. So if you're going looking for that material and it only comes in, say, 1 meter wide, you will not be able to use it because we can't create this patchwork of adding. Then you're going to end up with a seam somewhere along this line of the material. It's not going to work. Right, let's see what the question is. So we've got a waistline. This is not very clear, so I'm going to just try and add some, right, this is the waistline. There we've got the hip. That's the crotch. And this is the knee. Right, so those are what's missing and what you can't see. I'm sure you can't see it clearly. The total length of the outside leg is 1.4 meters. The outside leg is that over there. So that's 1.4 meters. Now, I always like to add my labels to my diagram as I'm going along. It just makes it easier. Then I've got everything there and it's easier for me to actually do the calculations. The pattern requires a waistband of 4 centimeters. So my waistband here is 4 centimeters. Let's change color because it seems to be getting confusing here. So we've got 4 centimeters, I'll add it there, of the waistband. And finally we have a turn up at the bottom of the leg of 25 millimeters. What is the length of the outside leg from the bottom of the waistband to the top of the turn up? Right, so we want to go from the bottom of the waistband to the top of the turn up. So what does that basically mean? We're going to have to minus the waistband and minus the turn up. So let's redraw this slightly. So we're going to have this 1.4 meters. We've got to minus the waist and minus the turn up. Let's put our numbers in. So we're going to say 1.4 meters minus the waist, which was 4 centimeters, minus the turn up, which was 25 millimeters. And bells are going off in my head, and I'm hoping they're going off in your head, because what's the problem? I cannot minus centimeters from meters. I cannot minus millimeters from meters. Well, what do I need to do? I need to convert. Now, my question to you before we start converting is, have they anywhere in the sum asked us for what the final measurement should be in? And I don't think anywhere in the sum have they actually said, give the final answer in meters or in centimeters. So we can use any one of the units. But it makes sense for me to use meters, because I'm quite happy to say that the length of the pants is 1 something meters. So let's convert everything to meters. So I'm going to do that on the side. Right, so I've got 4 centimeters. I need to convert that to meters. So I'm going to divide by 100. Why? Because there are 100 centimeters in a meter, and I get an answer. I can use the calculator if you'd like. 4 divided by 100, and we get 0.04. 0.04 meters. And 25 millimeters, now we're going to convert that. So 25 millimeters, and we're going to convert. Now, there are 10 millimeters in a centimeter, and there are 100 centimeters in a meter. Therefore, there are 1,000, I've just added the zeros, there are 1,000 centimeters in a meter. And let's do that on the calculator. So 25 divided by 1,000, and get our answer, 0.025. 0.025 meters. So now what did my question say? I'm going to take my 1.4, I'm going to minus 0.04, and I'm going to minus 0.025. So let's get that answer. 1.4 minus 0.04 minus 0.025, and I get an answer of 1.335. 1.335 meters in length. Now, am I going to round this off? Now, no, your questions always say to you, you need to use 2 decimal places. That'll be your instruction in every test and every exam. I don't think in this case I'm going to round off. And the reason I'm not going to round off is that we needed to have, what was the beginning it said to us? Extremely or very good at measurements. So I have a feeling that this tailor is going to go to the millimeter in his measurements. So I am not going to round off. If you feel uncomfortable not rounding off because your instructions always say round off to 2 decimal places, and you're scared that you might lose a mark for not rounding off, then all you need to do is say to your examiner or your teacher, I'm not rounding off. And you can go, because, and give the reason for it. And then your teacher knows that you knew you needed to round off if those were the instructions. But you specifically chose not to round off, which I think I would probably even give you a bonus mark for that, because I think that the logic behind that is perfect. And let's move on to the next part. Right, so the question says, the table below shows the distance between towns and cities in Scotland measured in miles. Now, in my introduction to this distance part of the question, I never said anything about miles. So miles are used in, let's go with other parts of the world. We don't have to worry about how many miles are in a kilometer. We just have to know that there is a distance measurement out there that's called a mile. So our calculations today are all going to be, our answers are going to all be miles. So don't let it throw you if it's something that you haven't seen before. So what does this table show us? Well, we've got different cities or towns. We've got Aberdeen, Carlisle, Edinburgh, Glasgow, Kendal, Perth, etc. So, and they've got a whole lot of numbers below them. How do we read this distance table? Well, what we do is we take from one town to the other. So let's just look at one example quickly so I can show you. If I'm going from Perth, across the line going this way from Perth, whoops, that's not a very good line, is, let's try that again. Right, Perth is 177 miles from Kendal. So from Perth to Glasgow is 62 miles. And if I want to know from Aberdeen, what I do is I draw a line down from Aberdeen and draw a line across to Perth, and I read that value and I see that it's 84 miles. So now that we understand how this table works, let's see if we can answer the question. So Jock is invited to travel from South Africa to Scotland to visit his cousins who live in Aberdeen. So let's delete all these lines. They live in Aberdeen. I'm going to mark that. He lands in Edinburgh and hires a car. So he lands here and hires a car. How far is it from Edinburgh to Aberdeen in miles? So what do? We go across from Edinburgh, down Aberdeen, and across to Edinburgh, and we read this value, and we see that it is 129. And remember, we're dealing in miles, so always need a reference. Right, let's see what our next part of our question is. Right. During his holiday, he does some sightseeing and travels from Aberdeen to Thurso, to Glasgow, to Kendal, to Edinburgh, and back to Aberdeen. So let's see on the map. He goes all over Scotland. Lucky man. So there's our map, and he goes from A to B to C, D, E, F, and then back again. Calculate the total distance he traveled in miles. So what they've done for us in the question is actually very nicely, they've broken it down from us. So each part of our section has been broken down because our total distance will be every single part of the section added together. So let's do A to B. So A was Aberdeen and B was, can't pronounce that, Russo. Right, so we do A to Aberdeen, it's 227. So that is 227 miles. Don't forget your unit. Although if you leave your unit out at this point in the question, I'm not too unhappy with that. But don't forget at the final part of the question, when you give your final answer, you need to add the units. So we've got 227. Where's B to C? So B, he was now, there's B. So maybe we should label this. Let's label this like this. Take that away. We've got A is Aberdeen. We've got B there. We've got C is Glasgow. D is Kendal. And then left out that C. E is Edinburgh. And F is Aberdeen again. So let's now do B to C. So we're going from B to C, 296 miles. C to D, I'm going to change colors so we can see if it makes a difference. C to D, well now I'm going from Kendal to Glasgow, or from Glasgow to Kendal rather, is 140. D to E, we've got on D and we're going to E, so we're going to go across here, 137. Finally, and then we've already calculated Edinburgh to Aberdeen. We've already calculated, but let's do that. Edinburgh to Aberdeen again, 129. Now the question was, what is the total? So I need to add these all up. So now I'm just going to get my calculator out, And when you're adding a lot of numbers, just be careful and double check that you're entering the right number. What I actually like to do is I like to add the numbers twice, just to ensure that I've got the same number again. But I'm just going to do this very carefully, so we won't add it twice. 227 plus 296 plus 140 plus 137 plus 129. So what I've done is, as I'm entering, so I'm actually checking that the numbers are the same, and I get an answer of 929. So let's put my answer in. We've got total of 929, and what were those? Those were miles. So don't forget to add your unit. Have we answered the question? It says calculate the total distance he traveled in miles. We've done that perfectly. So next part of our question, I had a table there. Right, I think before we go on to the next part, I think it's actually time to have a little bit of a break. So go get a quick snack, go make yourself a cup of tea, or go stretch in the garden and go outside for a few moments, and then come right back because we need to carry on with the lesson. I'll see you shortly. Welcome back, grade 10s. I hope that you're ready for our last session, and we're going to now go through time and speed. Those are the two that we haven't done yet. Hope you had a little bit of a break and that you're actually rearing to go. So had a little stretch. Let's sit down, let's focus, let's carry on with time. So right now, time. How do we measure time? Okay, well, we can use a watch. We can use a stopwatch maybe. Stopwatch. There's actually a few others, but while we're talking about watches, I'll come back to the others. We've got different types of watches. We've got an analog watch, which is basically one with where you've got your face and you've got your hands and it tells you what the time is. We've got digital clocks that give you a different reading, and we've also got where we've got a digital clock, we've also got the difference between AM and PM, or where we've got like 12 hours where we would use AM and PM, or we can use a 24-hour clock where we basically go up to 24 hours. So there's a whole lot of different ways, and I know each person's got their specific way that they like to read the time. So you use whatever you can, but you need to be able to interpret from one to the other and be able to understand any type of clock. There's another measurement of time. What about something, a calendar? Hey, so we basically, what I'm trying to tell you is that we've got more than just time as in what is the time right now. We can use a calendar. So let's discuss our units for a second, right? We've got minutes and hours. Definitely those are units of time. We've also got seconds. Again, units of time. But then we've got hours. What about days? What about weeks? And finally, what about years? These are all part of time. And then again, we can go on to centuries and we can carry on further. So let's quickly do a recap like we did in the last. Right, we've got 60 seconds in 1 minute, 60 minutes in 1 hour. We've got 24 hours in 1 day. How many? We've got 7 days in 1 week. And we've got 52 weeks in a year. And then finally we can carry on to how many years in a decade, how many years in a century. We can carry on, but these are all dealing with time. And the best thing is, let's go look at some questions. So our first question says, Bob and Danny service motorbikes. It takes Bob 30 minutes to clean the air filter and 1 hour 30 minutes to complete an oil change. How long will it be before the bike is ready? So now we're assuming that this time that they've given us includes all his stopping and going and getting the proper tools and whatever it is. So we're going to just answer exactly what they've asked. It takes him 30 minutes. Hey, that's not a 30. 30 minutes to clean the air filter, plus it takes him 1 hour and 30 minutes to complete the oil change. So all we need to do is add these two. So I'm going to end up with 1 hour plus 2 30 minutes, which gives me 60 minutes. So it's 1 hour and 60 minutes. And what do I know about the 60 minutes? That is an hour. So in actual fact, that is 2 hours. It takes him 2 hours to complete. Don't forget the units. Have we answered the question? How long before the bike is ready? Well, 2 hours after he starts, the bike will be ready. On average, it takes 2 hours and 36 minutes to complete a full major bike service. So now we're taking into account that there's a little bit more time that is needed for possibly getting the tools or taking a little break or whatever it is that he does know nothing about bikes. So, how many bikes can Bob and Danny service in one day if they both work for 8 hours? So it takes them 2 hours and 36 minutes, and they both work for 8 hours each. Now in this case, I've got a little bit of a problem, kind of like little subtle bells are going off, because I've got minutes here and I've got hours there. And I've got hours and minutes, so I'm getting a little bit confused. What I'm going to do is I'm going to convert everything to 1 unit. And in this case, I think it's going to be easier for us to convert to minutes. So let's see how many bikes they can do in minutes. So what are we going to do? Well, we're going to say, there's a little bit more space, 2 hours in minutes, we're going to times by 60, and we're going to add the minutes that we have. Now let's do that calculation. We can use it on the calculator. We've got 2 times 60 is equal plus 36. So it takes 156 minutes on average to complete the bike. So it's 100, need a pen for that, 156 minutes. How many minutes are there in 8 hours? Let's times that by 60. So we've got, let's clear that, 8 times 60 to see how many minutes there are, 480 minutes. So we've got 480 minutes for them to work. Now, let's take the one and divide by the other to see how many bikes they can complete in these 8 hours. So, I'm going to take my 480 and I'm going to divide by 156. And I'm going to get an answer to that on the calculator. 480 divided by 156 minutes, and I get 3,07. Let's write that answer. We've got 3,07. Now, what does this 07 mean? Can we say he completes 3,07 bikes? Well, I suppose they can start on the 4th bike, but they definitely can't complete the 4th bike. So how many bikes, and the question says, how many bikes can they both service in one day? Well, they can each service 3 bikes. That's the maximum number of bikes that they can service in one day. So, but there are 2 of them, so we need to times that by 2, so they can both service 6 bikes. They can start on the 7th and 8th bike each, but they cannot service the bike. We need to round down. Have we answered the question? And both work in 8 hours. We have. Let's move to the next part. Oh, okay, the next question. The table below shows the times of train leaving Durban to Newcastle. Now, whenever we get a table, what do I like to do? I like to analyze it first. So what do we have here? We have a timetable, and it's a train that's going from Durban to Newcastle. So we can see all the towns in between. So we've got Durban to Pinetown, Pietermaritzburg, etc. And for each one of these, we've got a different time. And basically that means the train is stopping in each one of these towns, and that is the time it is stopping in. So let's just analyze A for a second. We start at Durban at 9 o'clock in the morning, and then reach Pinetown by 20 past 9, Pietermaritzburg by 10 to 10, and we carry on like this. What time will it reach Newcastle? At 13:33. Hey, so it gives us the time. What kind of clock are they using? They're using a 24-hour digital clock. So let's answer the question. Which train do I need to catch to arrive in Newcastle before 3 p.m.? So first of all, what I need to do with that 3 p.m. is I need to convert that 3 p.m. into a 24-hour clock. So that'll be my first step. So I'm going to say 3 p.m. And what do we do in this case? We just add 12. Is actually 1,500 hours. And I need to be there before. And I need to be in Newcastle. So let's look at my Newcastle times. I've got one at just after 1:30, just after 3:30, and just after 6:30. So that's definitely out. Can't catch that train. This train, I need to be there before 3, so that's out. So therefore, which train do I need? So therefore, it is train A. It is the only train that'll get me there in time. Okay, let's delete these. I'm sure we're going to need the question again. How long does it take to get from Durban to Howick? Okay, so we got Durban to that point here. So we're going to go from 9 o'clock to 10:35. So we're going to do that on our, okay, so we're leaving Durban at 9 o'clock in the morning, and we're going to get there at 10:35. So what we need to do in this case is we need to take our 10:35 and minus our 9 o'clock. Now guys, when you're working with time, you've got to be careful on your calculators, because this 35 is actually 35 out of 60. It's not 35 out of 100. So we can't say 10,35 on our calculator. We need to say 10 hours and 35 minutes. So we need to work with them separately. But in this case, because I don't have minutes here, it's not such a hard calculation. So I can minus 9 o'clock, okay, and basically end up with still our 35 minutes, and we've got 1 hour. And if you actually use your numbers, I know like my kids go, well, okay, we start at 9, so it's 9 to 10, that's 1 hour, and then 35 minutes. Kind of like use your fingers to think through the time difference. You know, if we're going from 2 o'clock in the morning to 6 o'clock, or 2 to 3 to 4 to 5, my kids do that, works fine. Hey, I tend to do it myself. So 1 hour and 35 minutes. Right, let's see what the next part of the question is. Joseph and Maggie decide to get off the train. I think we should have off. Let's change this. Right, they're getting off the. Let's rewrite that. They get off the train in Howick, and they want to see Howick. They want to see Howick Falls and have lunch. According to a tourist guidebook, they need about 2 hours to enjoy a tour, which includes lunch. So what's nice about a question like this is as soon as they come up with something like breakfast or lunch, we've got to think, well, we know when about is lunchtime. So lunchtime, I'm going to be expecting this lunch to be somewhere between like 12 and maybe 1 o'clock, 1 p.m. Okay, 12 and 13, and we should actually be using a 24 o'clock. So between 12 and 13, that's when I would expect to sit down for lunch. Now they want to be able to do the tour, which is 2 hours including lunch. One thing with this question is it doesn't tell us whether the tour is before lunch or whether the tour is after lunch, or whether kind of you like do half the tour and then have lunch and then the other half of the tour. So there's a slight little bit of a problem with this. And I know, guys, that sometimes those things throw you. And what I want you to do is just ensure that you, okay, take a deep breath, and I want you to think, well, what do they mean? And let me just tell them what I assume they mean. So tell the teacher, your examiner, what you have assumed. So, because the question says, which train should they board in Durban? Now, I'm going to assume, so we're going to assume that we're going to have lunch and then the tour. So that's what I'm going to assume. I'm going to assume that lunch and then the tour. But you could do it the other way around. You could say the tour and then lunch. So I need to get to Howick at about lunchtime, somewhere between 12 and 1. Okay, so let's go back to our table. We've got Howick, right, that's 10:35, a little bit early for my assumption, 12:35 looking good, and 3:35, no, that's too late. So I'm going to say if they want to do lunch and then the tour, they need to be using train B. So that's what I've assumed, and it's train B. Now, if you had assumed that maybe they're going to do the tour and then lunch, well, then clearly train B is too late, and you need to be train A. But when you've got this like either or question where there could be 2 correct answers, then guys, tell the teacher what you've done. Because if your answer is different to her memo, she might not have thought about the other way. You know, we're so busy setting, and we kind of make a lot of assumptions that we know what you know what we're thinking. And often there are more than one way of getting an answer. There's more than one way of seeing something, and the teacher doesn't always see it. But if you explain what you've done, then it actually makes it easier to now update the memo, add another answer, and give you the marks. So, that's the next question. How long will they need to wait in Howick Station if the tour takes 2 hours and 10 minutes? So, we need to ensure that they have taken train B. So now we've assumed they took train B and they got there 12:35. What time is the next train out? Well, the next train out is at 15:35. So we're going to be taking train C at 15:35. So how long are they actually in Howick? Well, they're actually there. Let's minus this 12:35. They are there for 3 hours. Now we know that the tour takes them 2 hours and 10 minutes. So all we need to do in this case is say, well, they're there for 3 hours, and we're going to minus our 2 hours and 10 minutes. And we're going to get that calculation. Now, you might think to yourself, well, I don't need to do it this way. I just want to show you how I would do this calculation as actually converting to centimeters. Where's my mind? To minutes. So what I'm going to do is I'm going to say, well, 3 hours is actually the same as saying 2 hours and 60 minutes. And then I'm going to minus and do kind of this long minus sum. So I've got 50 minutes. Try that again. 50 minutes. And my 2 minus 2, I've got no hours. So that's how long it takes. So can you see when I'm converting, I don't just use my calculator because I can't put that 2 hours and 10 minutes on the calculator so easily. I need to convert it to one or to the other. So that's one way of doing it. How do we measure speed? Well, one way to measure speed is the speedometer. Like in my car, it tells me how fast I'm going. Okay, so we measure speed with a speedometer, and that's one way of measuring. Speed is measured in units, right? Well, our units of speed are basically measured, for example, my car will be kilometers per hour. But if I'm riding my bicycle, I'm not going to be discussing how many kilometers I've done in an hour. Probably be discussing meters and minutes, maybe. Meters per minute. Okay? And if I'm flying in a helicopter or in a plane, I'm not going to be discussing kilometers per hour necessarily. I might be discussing it in a different format. Or kilometers per hour would probably work in that respect as well. So you just have to read the question and see what the units are. Now, remember that these units, just going back to this kilometer per hour, it actually is a kilometers per hour, means divide by the hours. And in actual fact, this is kind of giving you the formula for speed, which I know in your papers they will usually give you the formula of what to do when you need to calculate speed. But from the actual unit, we can see that we're going to take our distance and we're going to divide it by our time. I always tell my kids this is kind of your little cheat, because in the question it gives you the units and it tells you what you need to do. So that's something to just keep in mind. Right, let's move on to some questions. Right. Selena takes 1.5 hours to cycle 18 kilometers. What is her average cycling speed? So in this case, we need to find our thing for speed was, in fact, we just discussed it, the distance divided by the time. So I like to write out my formulas first, always, because it just makes it easier. So we're going in 18 kilometers divided by 1.5 hours. Now, at this point, if you'd like to leave out the units, like I said earlier in the lesson, that's not a problem. But in your final answer, you must have the units. Let's get our calculator out and see we've got 18 divided by 1,5, and we get an answer of 12. And what does that answer mean? That's 12. What was our kilometers per hour? And that's probably 12 kilometers per hour faster than I would be able to go on a bicycle. So let's see what our next part of our question is. Michael cycles 15 kilometers at an average speed of 18 kilometers per hour. How many minutes does his journey take? ours has taken a slightly different approach to the one we had earlier. So I'm going to give us our formula again. I'm going to do that. Speed was actually our distance divided by time. So if I manipulate this formula, and my impression is that they would probably give you the formula in its correct format. So what we need to do is get rid of time. So we're going to times that there, times it over there. So we've got time, or speed times time. Let's do that way. Speed times time equals distance. And it might be easier for you to do if you had numbers in. And we want to know the time, so we're actually now going to divide by speed and divide by speed. So what I'm telling you in finally is that your time is actually your distance divided by the speed. Now, let's go back to find our answers. So we had 15 kilometers. Let's use a different color. We had 15 kilometers and 18 kilometers per hour. So our distance was 15 kilometers and our speed was 18 kilometers per hour. And we're going to get an answer. So let's do that on our calculators. 15 kilometers divided by 18, and we get an answer of 0,833. So let's write that in. Little paper. 833. Now, I'm not rounding off, and I'm coming back to this in a second. Just need to point out something important to you now. When you read this question, because I know what happens to my kids that are in grade 10 that I teach at school, they know they need to divide one by the other. They know that, like kind of instinctively. You know that you need to take the one value and divide by the other. But they always say to me, which value must we divide? And this is for a case where you don't have the formula like this question. So my answer to you in that case is make sense of the answer. Now, he's cycling 15 kilometers in total, and his speed is 18 kilometers for an hour. Am I expecting an answer that is more than an hour or less than an hour? Now, he's traveling less than 18 kilometers, so I'm expecting a number that is less than 1. If I get an answer of more than 1, then I've made a mistake in my actually which ones I've divided. So let me just show you. If I took it the other way around and said 18 divided by 15, I would have got an answer of 1,2. Now I know that that is wrong because I've made sense of the answer. So it was the other one that was 15 divided by 18. Okay, and I get an answer of 0,833 hours. Now, this is really, really important. That 0,833 hours is not 83 minutes. That is definitely not 83 minutes. We can leave the answer like that because what did the answer say? It said, no, we can't. It says, how many minutes did his journey take? So how am I going to convert that to minutes? Well, from hours to minutes, I'm going to times by 60. So I'm going to take that 0,833 and times it by 60. So let's get our calculator out. And on our calculator, I've already got that answer. So I can just times by 60, and I get an answer of 50 minutes. So it took him 50 minutes to complete. I'm expecting something that is less than an hour. So reread the question. How many minutes did his journey take? We got the answer. And we got the answer in the unit that they wanted it. Move to the next part of the question. So, right, the distance time graph shows the journey of a train between two stations. The stations are 6 kilometers apart. Whenever you've got a graph, I'd really like you to analyze the graph first and see what does our graph tell us. So we've got the distance in kilometers, and remember it said to us they were 6 kilometers apart, so I'm expecting it to go up to 6, and we got the time in minutes, and that's going up to 10. And we got start at 0, is why we're starting at the 1 station, and we move on to the 2nd station, and that's 6 kilometers apart. So during the journey, the train stopped at a signal. For how long was the train stopped? Well, we know the train's traveling here because why? My distance is increasing and my time is increasing. We know that the train increased there, but at this point here, our distance is staying constant. 4 kilometers, the train does not move. But what happened? My time does go up. So what does it go up? 6, from 4 to 6. So how much time was that? 2 minutes. Right, let's see what the next part of the question is. When was the train traveling faster, before or after it stopped? Now, you can do calculations to work this out and work out the speed for both parts of the journey. But if we just look at the graph, let's see what happens. It takes us 4 minutes to travel 4 kilometers. And then it takes us 4 minutes to travel 2 kilometers. So at which point are we traveling faster? So we've got the same time, in fact, 4 minutes, but in the first part we go 4 kilometers, the second part 4. So this one is definitely before it is traveling faster. Right, let's move on to the next part of the question. What was the train's maximum speed? Give your answers in kilometers per minute. Well, in this case, I need to actually just work out the time where it was faster. So I'm going to take this part of the table. Oops, I've lost my pen. I'm going to take this part of the graph and I'm going to work out kilometers per minute. Well, how many kilometers did we go? To this point, we went 4 kilometers. And we need to know how many minutes is 4 minutes. And that's quite an easy calculation. So we've got 1 kilometer per minute. And don't forget to add the units. And I'm not sure why, but some of the kids that I teach end up doing these calculations perfectly and then go, well, no, speed's normally kilometers per hour. So that must be the answer, must be kilometers per hour. And then it doesn't make sense because it's not 1 kilometer in an hour. It makes a huge difference what the unit is. And so just be careful that you've got the correct units. Moving on to the next part of the question. What was the average speed of the train for the whole journey? Give your answers in kilometers per hour. And in this case, they ask for kilometers per hour. So let's see what our distance was. Let's find a little bit more space here. Right, we need our distance. What was our distance? It was 6 kilometers. 6 kilometers. And we did that in 10 minutes. Now that's going to give me an answer in kilometers per minute. So what am I going to do? I'm going to actually convert my 10 minutes into hours. And the way I do that is I divide by 60. So I'm going to get an answer. I can do that on the calculator by 10 divided by 60. And we get 0,6. I'm going to leave that as it is, 0,16, okay. Or in fact, what I can do in the calculator, let's do it this way. Don't want those little decimals. So I'm going to say, well, this is 6 kilometers divided by 10 over 60. So we can do that calculation. So, or on the calculator, if we had the 6 kilometers and we divided by that 0,167. Okay, I'm going to leave that there. Let's just take my 6 kilometers and divide by my answer. I've got the scientific calculator, so I can do that. I've got 36 kilometers per hour. So let's do that. Right, going back to the question. So we got 36 kilometers per hour. What was the average speed for the whole journey? And give your answers in kilometers per hour. So that takes us to the end of the question, and that actually takes us to the end of our session. So I hope that you guys have had fun today, and I hope that you have been able to work with all these different measurements. Remember, we did mass, and we did time, we did distance, we did speed, we did temperature, we did length. We've done a whole lot of different work, and remember, there's different units for each one. But what I want you to really do is to kind of like take a deep breath when you read a question. Read the question carefully, look for all the numbers, look for the clues like what kind of unit do they want my answer in, make sure you remember that, do the calculations one step at a time, and then always go back, reread that question, make sure you've answered the question like they've told you, what they want. And remember, if you're not clear what exactly they want, tell us what your assumptions are, because then we can help you understand. I always say to my kids, I want to know what you're thinking. Make sure that I can understand what you're thinking. Because in that case, I can find marks and I can see what you're doing. And guys, you need to practice. So you need to practice all the stuff. So I'm hoping that your teachers are giving you lots of practice, and just enjoy it. And I'm going to say goodbye for now. So I hope to see you again soon, and thanks for being with me today.